Given zeros, finding the polynomial of least degree. So let's think back on when we were factoring and finding our zeros with let's say a trinomial like this. So the first thing you do, if I want you to factor and find your zeros, okay, what would we do? Well, first we would try to break it down. We want two numbers that multiply to make 15. Well, to make 15 could be 15 times 1 or 3 times 5. Since that's a minus, we know that we have 1 plus and 1 minus. So I know it's going to be x and x. I know it's going to be 5 and 3 because 5 times 3 is 15 and 5 minus 3 is 2. Whenever this is a minus, it tells you two things. It tells you that one's a plus and one's a minus, and it also tells you that you need to subtract the two to make the middle. Because the only way to get a minus 15 is if one of these was positive and one of these was negative. So if we need to make a positive 2, this has to be a positive 5. This has to be the negative 3. Let's double check ourselves. The outers would make negative 3x. The inners would make positive 5x. If you add them up, you get positive 2x. That's what's in the middle. If this was a negative and this was a positive, that would have been a negative in the middle. So we factored it. Now let's find our zeros. What do we do to find our zeros? We take this and we set it equal to 0. So we have x equals negative 5. Now look at this. X equals negative 5. Negative 5s are 0. And positive 5 was the factored form. So if you look at this, if this is x minus 3, your other 0 is just going to be a positive 3. So they're my zeros. Remember, what does that mean? That means they are your x-intercepts. This is positive 3. This is a parabola. So it goes something like this. Sorry, there we go. All right, let's do this next one. So if I want you to factor this, this is a product of sum and difference. Whenever it's a perfect square minus a perfect square, it's this. And it factors to a plus b times a minus b. So this is going to be x and x plus 4 minus 4. Because think about it. If you do the outers, it's negative 4x. You do the inners, it's positive 4x. They cancel. That's why there's no term in the middle. So what would my zeros be? Negative 4 and positive 4. Okay, they're my zeros. That's factored. There's your zeros. Let's go to the next thing. This is what we're doing. Now, what if I give you the zeros? And I want to know what the polynomial was that these zeros go to. So we're going to have to figure this out. So let me give you an easier one to start with. Let me give you an example of an easier one before I get onto this. Let's say that the zeros I gave you were negative 4 and 6. And I said, here are your zeros. Find me the polynomial that goes to. What would you do? Well, if you know that negative 5 is a 0, it goes to x plus 5 in the parenthesis. So if negative 4 is your 0, that means it came from x plus 4. If positive 6 is your 0, that means it came from x minus 6. Do you see how it's the opposite there? And then now we have to do is we have to multiply that. X times x is x squared. The outers is negative 6x. The inners is positive 4x. And the last is negative 24. So we have x squared, add them, negative 2x minus 24. So that is my polynomial of least degree that has those zeros. So we're working backwards. So what would this look like? If I had positive 2. If I have a positive 2, that means it was x minus 2. If I have a negative 2, it means it's x plus 2. If I have a positive 3, it means it would be x minus 3. See how I'm doing the opposites? Now, what do you do when you have a 0? The only time you'll get a 0 is if you have a situation like this. So let's look up here and I'm going to give you another example. Let's say I have x squared minus 2x, and I want to know what the zeros are. All I can do is take an x out, and I'm left with x minus 2. All right, so if I want to find my zeros, if you set an x equal to 0, and that's your 0, that means there was an x by itself. So if I see a 0, I know that there was an x by itself. And then the other 0 up here, of course, would be 2. Okay, so they're my 2 zeros. So if you ever see a 0 by itself, that means there was an x by itself. Okay, sound good? All right, so the first thing we have to do is we have to FOIL this. And first, I always pick the 2 that I think are the easiest to work with, or I know that since one's a plus and one's a minus, it's going to come out something like this. It's going to be a product of sum and difference. So I try to do that first, and then we'll multiply by that. But you have your choice. So if I multiply these two, I have an x squared, my outers are 2x, my inners are negative 2x, and my last is negative 4. All right, because the middles cancel. Then I have x minus 3. I'm going to multiply that by. I'm going to multiply by my x last. I'm just going to put an x through. So we have to FOIL this. X squared times x is x cubed. My outers is negative x squared, right? Those guys. My inners are negative 4x. And my last is positive 12. But I'm not done yet. I got this x. So I'm going to put this x right out in front. I always do my x last. So that's just going to jump all these powers of x up 1. So that's going to be x to the 4th minus 3x cubed minus 4x squared plus 12x. And that is my original polynomial that these zeros go to. Let's do another one. All right. I like when I have the same numbers but the opposites. That means that it's going to be product of sum and difference. So this is going to be x minus 1. This is going to be x plus 1. This is going to be x minus 3. This is going to be x plus 3. Remember, it's always the opposite of the factor. So I'm going to do these two first. I'm going to do these two, and then I'm going to multiply them together. So if I multiply these together, this is just like my product of sum and difference up here. So it's going to be x squared minus 1 times x squared minus 9. Because basically it's just first times first, last times last, because your outers and inners are going to cancel anytime you have the same thing, but one's a plus, one's a minus. So now I'm going to FOIL this. X times x is x squared times x squared is x to the 4th. My outers are negative x squared, negative 9x squared. My inners are negative 1x squared. And my last are positive 9. So that's x to the 4th minus 10x squared plus 9. And that is my polynomial that goes with those zeros. So far, so good. All right, let's do another one. Let's do negative 4, positive 1, negative 2. So that's going to be x plus 4. This is going to be x minus 1. This is going to be x plus 2. Okay? So you have your choice. I'm just going to do the first two just because they're here. A lot of times I'll save that to do at the end, but it doesn't matter. If I multiply these out, I get x squared. My outers are negative 1x. My inners are positive 4x. That's positive 3x in the middle. Minus 4. And then I have to multiply by x plus 2. I'm going to put that in front. I like to have my smaller, my binomial, I like to have it in front of my trinomial. It's just a personal. If I multiply that times that, I have x cubed. And you have to be careful. Just take your time on this. And x times 3x is positive 3x squared. Then x times negative 4 is negative 4x. Okay, so we're done with that x. We multiplied it all the way through. Now we're going to multiply negative 2 times x squared. That's negative 2x squared. I'm going to put it underneath the other x squared so I can just add down. And then negative 2 times positive 3 is negative 6x. And negative 2 times negative 4 is positive 8. Okay? Double check ourselves. X times that is x cubed. X times that is 3x squared. X times that is negative 4x. Negative 2 times that. Negative 2 times that. negative 2 times that. Now I'm going to add down. That's my polynomial. That goes with that. Okay, let's do a little review real quick before I go into the next thing. Remember, if I have x squared minus 9, that means it was x plus 3, x minus 3. So my zeros were negative 3 and positive 3. But what if you have x squared plus 9? I know you saw the video last time on solving polynomials, finding zeros for polynomials when they were non-real solutions. All right, so that's what this is right here. I can't factor this like I did this. There's no way to factor that. Does not factor. That is in the least form, so that cannot be factored anymore. But if I want to find my zeros, remember this from last video, you have to set it equal to 0. I have x squared equals negative 9. The way to get rid of an x squared is to square root it. So x equals, now this is where we have this issue with our negative inside of our square root. Remember when we were doing complex numbers, the square root of negative 1 can be replaced with an I. So we're going to think about this as the square root of negative 1 times the square root of 9. Now, don't forget, since we took the square root and we put the square root on ourselves, don't forget you always need that plus or minus, okay? Don't forget that. Very important. The square root of 9 is 3, and the square root of negative 1, we can put an I in. So my zeros here are 3i and negative 3i, okay? Now I could have solved x squared minus 9 the same way. I could have set it equal to 0, add 9, and have x squared equals 9, then root it. So x equals plus or minus 3. Remember, see how I put the square root on? It was not there already. That's when you need that, okay? So remember, whenever you get a 0 that has an I involved, there's something we're going to have to do, and that's what's coming now. So let's say I gave you the zeros, positive I, negative I, and 3. What would that look like? Well, let's work backwards. So we know that if this is a positive I, we write a negative I there. I don't think you've ever seen that look like that before. And then if you have a negative I, you write a positive I. If you have a positive 3, you write a negative 3. Oops, x minus 3. Sorry about that. So I got to FOIL that. Okay, I have to FOIL that. Now, we know how to FOIL this. We've done this when we were doing complex numbers. So let's run through it. Remember, anytime you have an I times an I, you get an I squared. Do you remember what you can substitute in for an I squared? Anytime there's an I squared, you can put in a negative 1. Okay, so remember that. We have to remember that. So if you have 2i squared, you can simplify that as 2 times negative 1, which is negative 2. Okay, if you have 3i times 4i, that's 12i squared, which is really 12 times negative 1, which is negative 12. Okay, remember that from complex numbers? So let's FOIL this. X times x is x squared. My outers are positive xi. My inners are negative xi. What happens to them? They're exactly the same. Ones plus ones, they just cancel. And then my last term is negative I times positive I, which is negative I squared. So I have x squared minus I squared. Well, what do we say we can put in for an I squared? Anywhere we see an I squared. We put a negative 1. So it's x squared minus a negative 1. That's just x squared plus 1. So all that came out to be x squared plus 1. Because think about it. When we were solving this problem right here, when we had x squared plus 9, when we had a plus in the middle, not the minus, our zeros had the I involved. It was 3i. What's the square root of 9? 3. And they both needed an I. We have our last one. We have to multiply by x minus 3. So we're going to FOIL that. X squared times x. X cubed. Outers, negative 3x squared. inners, positive 1x, and last, negative 3. That's my polynomial. Okay? Let's go to the next one. I have 2 and negative 2, so that means it's x minus 2 to give me that, x plus 2. Now, do you see how I have a lone 3i? You should never have an I by itself. They're trying to trick you with something like this. Whenever they give you, do you see how up here I had an I and a negative I? And when I solved this, I had a 3i and a negative 3i. Whenever you have an I, its partner has to be there. So a lot of times they're only going to give you one of them and they want to see if you know the other one. Okay? So if they only give you one term with an I, you have to write its opposite with it. You have to write its pair, so to speak. So then this comes out to be x minus 3i, because where there's one, there needs to be the other. And then we write plus 3i. Okay? So I'm going to do these two together. So remember, one's a plus and one's a minus. So that just comes out to be x squared minus 4, because my outers, my inners cancel. This, same thing, I'll do this out for you again. X times x is x squared. My outers are positive 3ix. My inners are negative 3ix. They cancel. And my last are negative 9i squared. So we have x squared minus 9i squared. Anywhere you see 9 squared, you got to put a negative 1 in. So negative 9 times negative 1 is plus 9. So we have x squared minus 4 times x plus 9. So we have x cubed plus 9x squared. Right? My inners are negative 4x. And my last is negative 36. And that is my polynomial. All right, let's just do two more. We have a positive 1 and a negative 1. So we have x minus 1, x plus 1. This is x minus 2i. Wherever there's an I, there has to be its opposite. So if there's a positive 2i, there needs to be a negative 2i. All right? They're going to do that to you. So that has to be x plus 2i. Okay? So you should be getting the hang of this. This just comes out to be x squared. Outers and your inners cancel. So that's just negative 1. Okay? This comes out to be, basically we know whenever we multiply two things that one's a plus and one's a minus, the middle terms are going to cancel. So really all you have to do is first and last here. So we're going to do x times x, which is x squared. Because remember, my outers, I'll do this one through again. My outers are going to be positive 2ix. My inners are negative 2ix. And my last are negative 4i squared. So what's happening to them? They cancel. So this is going to be x squared. What's happening here? I have an I squared. So negative 4 times negative 1 is positive 4 times my x squared minus 1. So that's going to be x squared times x squared is x to the 4th. My outers are positive 4x squared. My inners are negative 1x squared. We're going to combine them. And my last is negative 4. Let's simplify that. X to the 4th, they combine to make positive 3x squared minus 4. Okay. Last one. If we have an I, now we can't just have an I by itself. So we know that there has to be a negative I as well. And if we have a 4i, we know we shouldn't have a 4i by itself. We know there should be a negative 4i. So they were trying to trick us on this one. So remember, just because they have i's doesn't mean, oh, I just write x minus I, x plus 4i. No, if there's a 4i, there needs to be a negative 4i. If there's an I, there needs to be a negative I. So that's going to be x plus I, x minus I, x minus 4i, x plus 4i. So that's going to come out to be x times x is x squared. My outers and my inners cancel. All right, because if you look at that, we have negative ix, inners positive ix, they cancel. I times negative I is negative I squared. So I have x squared minus I squared. What goes in for there? Remember, anywhere we see an I squared, Put -1 in. So that's x squared plus 1. And then this is going to be x squared, outers positive 4ix, inners negative 4ix, cancel, and last is negative 16i squared. So that looks like x squared minus 16i squared. So that's going to be x squared plus 16. All right, because right here it's really negative 16 times -1. So we have that times this. I'm just going to FOIL this. X to the 4th, outers positive 16x squared, inners positive x squared, last positive 16, x to the 4th plus 17x squared plus 16. So if I said factor this, they're the zeros you should have gotten. If I said factor this, they're the zeros. If I said factor this polynomial, they're the zeros you would have gotten. So we worked backwards on this. So I hope you have a better understanding of finding the polynomial when the zeros are given.